Hello, good morning student. How are you? I hope you all are happy and fine at home. What did we discuss yesterday? We discussed about the peptide synthesis. There are different steps to protect the amino acid as well as activated by the carboxylic group. How we are getting the desired peptide synthesis step by step we have learned so far. What we are going to learn, that is how racemization is avoided during the peptide synthesis. So question, how racemization is controlled, how racemization is how racemization is avoided during peptide synthesis, that we already learned. That question may appear in your exam, how racemization is avoided during peptide synthesis, or the question may appear in another way, how racemization occur, occur during peptide synthesis, and as we know that there are different protecting. So how racemization is avoided during the peptide synthesis, or how racemization occur during a peptide synthesis if you activated the carboxylic group and protected by the amino group, then you will get desired product. But sometime if you try to try to protect the carboxylic group and activated as amino group, and then there will be a how racemization, and we know that racemization means what? We are getting as a enantiomer means equal proportion of equal proportion of mixture. So that type of the species is known as a racemization. How racemization occur during a peptide synthesis, that we already learned. So let's see here how we can avoid this. For peptide synthesis, common protecting groups used are, for peptide synthesis, common protecting groups used are, group used are for peptide synthesis. The common protecting group used are, for example, let us see first one is a tertiary butyl ester. As we know that tertiary butyl ester, as we know that, like this is a tertiary butyl ester. It is used to protect the for COH protection. This is for COH protection. for COH protection. The tertiary butyl ester is used to protect the carboxylic group. Then second will be frequently used benzyl ester. Then benzyl ester, here C double bond O BN. So benzyl ester can be used to protect the carboxylic group. Then third one may be beta, that is a trichloroethyl ester. Ethyl ester that could be used. So BBR, we can call it 2,2,2 trichloro. Suppose here let us see Cl, then Cl, then CH2O, then C double bond O, maybe as a azide over here. So that type of the compound is called as BBB trichloroethyl ester, or we can call it as a 2,2 trichloroethyl N-diazocarbamate. And let us see for NH2 group, protection for NH2 group. Let us see, because in amino acid there are two functional groups are present. One is a carboxylic group and another one is a NH2 group. For protection of the common protecting group for COH group, just now we have seen. Now let us see some of the common protecting group used for NH2 group. Let us see here for NH2 protection. Here, as we know that first one is a CBZ protection, then phthalate protection, CBZ protection, then second may be as a phthalate protection. These are the some of the, then FMOC, BOC, these are the other protecting group is used for protection of NH2 group. Then amide protection is not used. Amide protection is not used in the amino acid because D protection needs vigorous acid or base hydrolysis that may cleave peptide bond. As we know that peptide bond, which is peptide bond C double bond O NH2, this is a peptide bond. If strong acid and base hydrolyze, that may cleave the peptide bond, hence never used for protection of NH2 group. Then let us see here, suppose we have carbon monoxide. As we know that this is the carbon monoxide will be passing over chlorine at active charcoal at 200 degrees centigrade. What do you get? What type of the product do you get? The product will be formed like this, C double bond O Cl. As we know that the name of this product is a phosgene, is a very toxic. This is a it is a phosgene, very toxic in nature, but it is used as a protection for amino group. When it is treated with this phosgene, further treated with benzyl chloride like this, so the resulting compound is obtained known as CBZ, means benzoyl. Here you are going to get this one pH, then Here you are going to get O, then C double bond O and Cl. This lone pair is directly attacking on this chlorine. This get removed. So this is known as a Cb benzoyl carboxychloride. So CbZ group, and it is used for the protection of amino group. For deprotection of CbZ, this is a CbZ group we got here, carboxybenzylic group over here. For a deprotection of CbZ group, if a condition, yes, that is cysteine, then hydrogenolysis cannot be used. Here hydrogenolysis cannot be used. Then the reagent used are pH4 ion, tetraphenyl iodine, tetraphenyl in presence of iodine. This is a reagent used for removal of this group. Or we can use sodium in presence of liquor ammonia. This is another reagent used to remove that benzylic type of the compound at minus 40 degrees centigrade. Reaction is carried out at low temperature near about 40 degrees centigrade, and or we can use hydrogen bromide in presence of acetic acid. In presence of acetic acid, you can use either removal of, or for deprotection of CbZ, we can use tetraphenyl in presence of I2, or sodium or the dissolved metal in presence of liquor ammonia at minus 40 degrees centigrade, or hydrogen bromide in presence of acetic acid, or you can use ET-thriene, that is a triethyl silane at palladium chloride, in presence of palladium chloride. So these are the some of the deprotecting group used for removal of this type of the CbZ group. All reagent must be used at cold condition, means at a low temperature. Now the protection of group in a side chain. Whatever we have seen, that is a protection of this amino acids. Now let us move on to the next point, which is the protection of group in a side chain. Protection of group in a side chain. First one, protection of group in a side chain. Protection of group in a side chain. First one, number one, protection of group in a side chain. So let us see, this is the first point. First point, selective protection of alpha or gamma COH group in a side chain of glutamine, or alpha or beta COH group of aspartic acid. These are the amino acid, and the protection of gamma COH group. Now is the protection of gamma COH group. This how it is get protected. Let us see here. First one is a aspartic acid. As we know that the structure of aspartic acid NH2, then CH, C double bond O, OH, then CH2, C double bond O, OH. This is the structure of aspartic acid, and this amino acid can be treated with pH, CH2OH, benzoyl alcohol in presence of acid. It protect the carboxylic group here like this. So H2N, then CH, C double bond O, CH2PH. Then let us see here, this CH2 twice you can write, C double bond O, then CH2PH. The carboxylic group, both the carboxylic group get protected with benzoyl alcohol in presence of the H plus, then gamma hydrolysis. Now hydrolyze it. Hydrolysis at gamma hydrolysis you can call it as a gamma hydrolysis. And the reagent used here HI in presence of ACOH, acetic acid, mild, this is a mild hydrolysis. Mild hydrolysis, what do you get? Specifically, this one is a, let us see here, let us see alpha, this one is a beta and gamma, two CH2 are there, beta and gamma. Specifically gamma group get hydrolyzed, we are going to get the product selectively H2N, CH, C double bond O, then CH2, PH, then here CH2, C double bond O, OH. This group get free over here, and then this group further treated with this one double bond in presence of H plus isobutylene or 2-methyl propene. What do you get? This group get protected over here like this, H2 N, then CH, C double bond O, CH2 PH, then further CH2, C double bond O, and then this tertiary group, right? This is a tertiary group get protected, or CM, instead of this you can write CMe3, tertiary butyl group over there, right? And now after that what is going to happen, then you can carry out the hydrogenolysis process over here. After the hydrogenolysis, what do you get? Here hydrogenolysis, H2 palladium in presence of carbon, or that is a palladium in presence of carbon. What the hydrogenolysis takes place, and you are going to get here H2N, then CH, then sorry, here is something is wrong here. Here is this C, let me clean first here. Here H2N, then CH, then this one CH2, C double bond O, then O, CMe3, and then this C double bond O, CH2PH. This is the group. And after the hydrogenolysis, H2 palladium in presence of chalcone, what do you get here? You are going to get here NH, then CH, this CH2, C double bond O, then C Me3 as it is, and therefore here we are going to get C double bond O OH. Selectively gamma glutanyl residue is selectively protected over here in this way, right? And that is a protect. We have protected this, and now COH group and NH2 group are free over here, so you can carry out the reaction with the other peptide and we will get the desired product. So that is there. Now let us see another point over here, which is that point. Let us see here protection of alpha COH residue. Next one is a protection of alpha COH residue. Now here let us see the aspartic acid. Once again H2N, then CH, C double bond O, OH, then CH2, C double bond O and OH. This is aspartic acid, and now this aspartic acid further treated with methanol CH3OH in presence of H plus. What do you get? That is a esterification, acetoacetic esterification reaction takes place. Esterification reaction carried out, and the resulting compound, what do you get? Selectively occurs at less hindered position, and therefore here this type of the esterification carried out at less hindered position. So here specifically selectively this group get protected with this reagent, and what you are going to get here H2N, then CH, C double bond O, OH, then CH2, C double bond O and Me, right? Me we are getting here, and this group further treated with this one H plus that is a isobutylene in presence of the acid. What do you get over here? And now when you do this will be get protected by using this one H2N, then CH, C double bond O, CMe3, as well as CH2, C double bond O, CMe3. Both the group get protected by using this one, and now again this reaction can be carried out with the basic condition deprotection, less hindered get hydrolyzed, and less this is a less hindered group is hydrolyzed, and we are going to get this is a less hindered side H2N, then CH, C double bond O, CMe3, it remains as it is, and this CH2, then CH2, C double bond OH. These groups selectively get deprotected with this base. In this way we can protection of the alpha COH residue in this manner. In a similar way, protection of COH group in aspartic acid can be carried out. Now let us look at as a second one, protection of NH2 group in side chain. Whatever we have seen all about the protection of COH group of side chain. Now let us see here the protection of NH2 group as a side chain. Now is a protection of NH2 group, protection of second one, protection of NH2 group, NH2 group in a side chain, protection of NH2 group in a side chain. Let's see here one more example, that is this one, H2N, then CH2 twice, NH2, then C double bond OH, that is one of the, sorry, here is a 4 times, CH2 4 times, NH2, then this group treated with cuprous chloride CuCl2 in presence of Cu chelate, copper chelate. What you are going to get over here after treating this, the product formed will be this one, H2N, then CH2 4 times, and then there will be a C double bond O, then a 4-membered O, there C, let us see here N, H, positive charge is formed here, this type of the complex form here. Then now this will be treated with trimethyl, this one, Me3 trimethyl type of the C double bond OCl, this type of the group. When this complex treated with this, the resulting compound obtained will be, because this is used as a protection for H2N group. Now what do you get over here? This Me3C, then O, C double bond O, then NH, this NH, one of the hydrogen atom from here and one of the chlorine from there eliminate as a HCl fumes, and we will get NH, then CH2 4 times, rest of the part remains as it is, C double bond O, then C this bond, then N, H, positive charge over here. That is the complex form, and this complex further treated with HCl in cold condition. Ice is used over here during this reaction. The cleavage of metal complex by HCl, the resulting product will be obtained as BOC, then NH, then CH2 4 times, then CH, C double bond OH, and this NH2. That amino acid get free, and that NH2 group get blocked by using these steps. Now selectively only NH2 group is NH2 group can be protected, and so this way we protected the NH2 group. Now let us look at third one, that is protection of SH. Third point will be, third one, SH group protection, thiol group protection, thiol group protection, and this thiol group, and as we know that generally SH that will be treated with pH, then CH2Cl benzyl chloride, this will be treated with base. Again base will abstract the proton and this is going to attack over there and you will get yes, then CH2 and pH. This type of the thiol get protected. This is known as a thioester. The product form is called as a thioester. This is a thioester. Now this thioester or trityl chloride can be used. Instead of this, the trityl chloride can be used for the protection of this thiol group, and this will be further treated with at a lower reaction carried out at lower temperature, minus 40 degrees centigrade, that is a sodium in presence of liquid ammonia NH3, you will get the deprotection of this thiol. So that is a SH we are getting as a back. So this is about the protection of thiol. Now fourth one, OH group protection. Fourth one is a OH group protection. OH group protection, and as we know that this OH can be treated with benzyl chloride pH Cl in presence of base. Again base, what do you get? You are going to get here O, then CH2, pH. This is a protecting OH group, and deprotection can be carried out by the hydrogenolysis H2 palladium in presence of chalcone. This process is known as a hydrogenolysis, and you will be getting as a alcohol back over there and the toluene. And now fifth one, protection of gonidino group protection. Fifth one, protection of gonidino group. Fifth one will be the protection of gonidino group. For example, suppose we have this one H2N CH COOH, then there is a CH2 thrice NH is another base using here HN, then NH2, right? Now this, sorry, here is a something wrong here, NH, then this one HN, then NH2, gonidino group. This type of the group is called as a gonidino, or this is the structure of RJ9. This is the structure of RJ9, which is one of the amino acid which is basic in nature, and protection of gonidino group is done by maintaining pH at which gonidino group gets fully protonated and protected. So in this way we can protect this RJ9 by the gonidino group. I think with this let us stop today here. Remaining we will see the next lecture. Thank you. Have a nice day.